Alright, so in this video what we're going to look at are some density applications. The important thing you're going to need to remember and really understand about density is that density is representing the ratio of mass to volume for a substance. We're showing that ratio when we talk about density as mass being divided by volume. So with this idea that density is a ratio of how much mass to how much volume for a substance, we can do some neat things. In addition to that, the other thing that's important to understand about density is that it is what is known as an intrinsic property. So an intrinsic property is one that is going to be the same no matter what form you have of that substance. So let's look at an example here. Say I have just this kind of hunk of metal. Let's say it's a hunk of aluminum metal. Aluminum has a density of 2.7 grams per centimeter cubed. So what does that mean again? That means that for every 2.7 grams of aluminum that we have, it's going to have to occupy a space of 1 centimeter cubed. And of course, the other way to look at that is from the other side. Every 1 centimeter cubed of density that we have will have a mass of 2.7 grams. So we can use this information in some kind of useful ways, because now we know the ratio, 2.7 grams to 1. There's an imaginary 1 in front of the centimeter cubed. So maybe I take this block of aluminum and I figure out that its mass is, its volume is 3 centimeters cubed. Well, if I know the density ratio of 2.7 grams per centimeter cubed, I can use that to figure out how much mass. How we're going to do that is with a little bit of math, and we're going to kind of use this idea up here of density as a division problem. So we'll take our 3 centimeters cubed, and we're going to multiply it by the density of aluminum. So 2.7 grams, that's the mass, per every 1 centimeter cubed. So what that means, what this equation means, is that we would take 3 centimeters cubed, multiply it by 2.7 grams, and divide it by 1 centimeter cubed. Now there's a lot of units in there, but there's actually a nice thing. Anytime you take a unit out front here and then divide by that same unit, you will cancel out these units. So what that means is that if I take my 3 and multiply it by 2.7 and then divide it by 1, I'll get 8.1 as a number, and that, because we've canceled at our centimeters cubed, that 8.1 is a mass in grams. So what we just did there is we took a known volume of aluminum. We took a known volume of 3 centimeters cubed of aluminum, and we used our density to figure out, without measuring, but to calculate what the mass of our aluminum would be, and that's the 8.1 grams. We can actually do this going the other way as well. So let's kind of box off a second area here and talk about a little bit of using mass in the same way. So maybe I have this same sample or a different sample of aluminum that I put on a balance, and I determine the mass of that aluminum to be, let's say, 5.0 grams. So not a very big piece. I can use that mass of aluminum and my density, just like I did before, to figure out the volume of aluminum. So I'm going to set things up very similar. 5.0 grams of aluminum. We're going to multiply by that density fraction that we talked about earlier. But there's something important that we need to put in here. Something important we need to talk about for a second. Notice what happened over on our first problem. We took centimeters cubed and we divided by centimeters cubed, and that's what allowed them to cancel out. If we put the density in exactly as we did in the previous problem, we won't be canceling out our grams, because they won't be on the outside. Well, they will be on the outside, but they won't also be on the bottom. So we need to change this ratio of 2.7 per 1 centimeter cubed just a tiny bit, and all we're really going to do is flip it upside down. Because it's a ratio, we can look at it from either end. 2.7 grams per every 1 centimeter cubed would be the same thing as 1 centimeter cubed per every 2.7 grams. So what we're going to do is flip that ratio upside down in our problem. We're going to put the 1 centimeter cubed on the top and the 2.7 grams on the bottom. So now look at what happens. Your grams of aluminum and grams will cancel out. So this problem will give you an answer that is in centimeters cubed. All you need to do now is take your 5, multiply it by the 1, and divide it by 2.7. When you do that, 5 times 1 divided by 2.7, you find out that you get 1.9 centimeters cubed of volume. So what we've done in this video is we've talked a little bit more about density and how it's a ratio of mass to volume, and we've used that ratio to essentially convert from centimeters cubed over to grams, so from a volume of aluminum to how much mass that sample must have. And then we've actually done it the other way too. We've gone from how much mass of aluminum over to how much volume that sample would have to occupy.